welcome to another GCSE Computer Science video on data representation with me, Mr Goff from mrgoff.com. Today's video will be focused on binary mathematics. The first thing we'll look at is binary addition. There's only a few rules you need to remember for successful binary addition. 0 plus 0 is 0. 1 plus 0 or 0 plus 1 would both equal 1. 1 plus 1 equals 0, carry the 1. And 1 plus 1 plus 1 is 1, carry the 1. So if we work through our example, we start on the right. 1 and 0 is 1. 1 and 1 is 0, carry the 1. 1, 0 and 1 is 0, carry the 1. 1 and nothing else is just 1. 0 and 1 is 1. 1 and 1 is 0, carry the 1. 1, 0 and 0 is just 1. 1 and 0 is 1. We can see that the answer to our sum is 1101, 1001. We can check our working by looking at the sum of the decimal equivalents of these numbers, and 163 plus 54 does indeed come to 217. Both processors and programs generally handle a certain number of bits at a time. This is known as a word size. You might be familiar with some programs on your computer that can either be in 32-bit or 64-bit mode. Because computers work with words of a set size, an overflow error can occur if we add two binary numbers and the result is larger than the word size we have available to store it in. This is the case in the example below, where a 9th bit would be generated by adding the two numbers together. One of the requirements for students listed in the specification is to be able to add 3 binary numbers together. The easiest way to do this is to break the task into 2 steps. First, add the first 2 binary numbers together, just as we've seen. Next, add the result of that to the third number. To add the 3 binary numbers 00101010, 0001101, and 01000001, we would first start by adding the first 2 numbers together. 0 and 1 gives us 1, 1 and 0 gives us 1, 0 and 1 gives us 1, 1 and 1 gives us 0, carry the 1, 1, 0 and 1 gives us 0, carry the 1, 1, 1 and 0 gives us 0, carry the 1, 1 and nothing else is just 1, 0 and 0 is 0. We have our number. We then use that in our second calculation, and we start again by adding the third number onto the sum of the first 2. 1 and 1 is 0, carry the 1. 1, 1 and 0 is 0, carry the 1. 1, 1 and 0 is 0, carry the 1. 1 and nothing else is just 1. 0 and 0 is 0, 0 and 0 is 0. 1 and 1 is 0, carry the 1, 1 and nothing else is 1. And we have our final answer, that is the total of all 3 of the numbers together. The final bit of binary mathematics we're going to talk about are bit shifts. Bit shifts allow us to multiply and divide by powers of 2. They do this by moving the bits in a number to the left to multiply or to the right to divide. As you can see in this example of a left binary shift, each time we shift the bits to the left by 1 place, the number doubles. We simply slide in an extra 0 on the right. Because of this, it increases by 2 if we shift it by 1 place, but 4 if we shift it left by 2 places, 8 if we shift it left by 3 places, 16 if we shift it left by 4 places, and this pattern continues, shifting it by powers of 2. The opposite happens if we perform a right binary shift, dividing the number by powers of 2. It gets divided by 2 each time it gets moved to the right, so by 4 if it gets moved twice, and by 8 if it gets moved 3 times, just like when we go left. However, you may have noticed the slight problem with shifting to the right. When the number is odd, we lose a bit, and the division is not exactly equal. It uses integer or floor division to perform the division and loses the remainder. That brings us to the end of this video on binary mathematics. I've been Mr Goff for MrGoff.com. I hope you'll join me again for more data representation videos. Our next video will be covering character encoding. Bye for now.